So we would like to find the arc length of a graph of this function here, okay, on the interval 0, 1. So here is a graph. So we just want to find this arc length, and actually it was better before. So the way we will go is, or rather a way we will go is, the rule mentioned on the page 170 that you saw deduced, okay, for computing the arc length. So first let's factor this 1 over 5 out of the equation. So if we factor 1 over 5, our expression becomes this, and what we are doing is, so what we are going to do here is that we are going to calculate the integral from 0 to 1 plus the derivative of f prime x, that is squared, with respect to x. Okay, so the first thing that I have to do is calculate the f prime x, where f is how much, where fx is given by this quantity, right? So if I do this, when I calculate the derivative, what do I get? By chain rule, you can see this will step down as a factor here, and the derivative of e to the u is e to the u, pardon my handwriting. And since here we have a negative sign, we will get a negative 5 over 2 e to the negative 5 over 2 x. And you can factor this 5 out, so we get 5 over 5, okay, and what we have here is e to the 5 over 2x minus e to the negative 5 over 2x, and whole thing divided by 2, and these 5s, they cancel, okay. So what we have for f prime x here then is that we got 1/2, right? I'm just getting it from our previous portion, and e to the, got too many brackets here, okay, e to the 5 over 2x minus e to the negative 5 over 2x. Now what we have to do next is we have to calculate the quantity 1 plus f prime x squared. Remember, that's what we have to integrate here. And all that we are going to do here is not really much calculus, more of algebra. That is, we are going to see that how does this quantity get simplified here. Okay, so first let's go ahead and square f prime x, or f prime x squared will be how much? Square of this quantity. And what is the square of this quantity? If you square it, here we get 1/4, and this would be squared. Now we can go ahead and what you call FOIL it, or multiply it out, or distribute. So this would be, so first we get a square of this quantity, e to the 5 over 2x, and when you square this quantity, what this will become? This will become simply e to the 5x, right? Okay, and then we will have negative 2 times e to the 5 over 2x times this, and I'm just writing the foiling finally, because there are 2 steps that will add with negative sign, and then plus a square of this quantity, which will become e to the negative 5x. All right, so what we got then is our quantity f prime x square has become this. Now if you pay attention, if you just look at this right here, these two just cancel each other, right? These two, when you multiply them, so here I have power 5 over 2x, here I have its negative, so when they add, then they cancel. Now what we are going to do is we are going to calculate this portion here, and that would give us, what will that give us? 1 plus 1/4 of this. Now, all that we have to do now is let's take 1/4 as, 4 as common denominator, right? Okay, so here we will have a 4 plus this whole thing. Okay, so when we do that, then what we obtain is, we obtain, the only thing that changes here is, or can be simplified, is that this -2 will become this +2. And then just, old style algebra here, which is, I hope is still enjoyable. All right. So here you can do this. That is, you can see this is the square of e to the 5x over 2. So you can bring this, just insert this portion back, because it's nothing but what? Nothing but simply a 1, right? And then what this will become then is, if you look at this, this just becomes back the square of, instead of negative, our sign changes to what? Positive here. Okay, sorry. Okay, because this sign is positive now, so this is squared and divided by what? Divided by 4. Okay, so the quantity is square root of 1 plus f prime x squared. That becomes what in this case is square root of this quantity, right? Okay, and this will be simply then just the quantity divided by 2, right? Okay, so that's what we have to integrate now. So let's go ahead and quickly find the integral of, 0 to what? 1, okay, of this quantity, okay, and that becomes, again, 0 to, and I'm just putting this 1/2 out as a factor just to make it look a little friendlier, or larger actually, okay, for older person like me. Okay, and now we will simply do what? Just recall that if we have, if alpha is a constant, then e to the alpha x dx would be how much? 1/alpha e to the alpha x, and of course plus a constant. So here this is 1/alpha, and as I said, alpha is a constant. So, I could have shown you the details by taking u equals alpha x. So this is a little substitution rule that you can work on to obtain this quantity. So in this case, what happens? Alpha is 5/2, and here the constant is -5/2. So when we carry this out, what will we get? So we shall have that you can factor this 1/2 out. All right. And then when I'm integrating, when I'm integrating e to the 5/2x, it will be 1/e to the 5/2, which will flip to what? Which will flip to 2/5, and this will remain exactly the same. All right. And then 2/5 I said, but I didn't write it. Okay. Then here it will be 1/-5/2. That will give us -2/5. So we got 2/5 here, and then we got -5/2x, and we are going to ignore the constant because we are calculating a definite integral here. So what we have is that we are going to simply evaluate this quantity between, or rather with 1 as the upper limit and 0 as the lower limit. Okay, and which will be, if we just bring it down to the next line, that will simply be this, that is here. Okay, let me scroll up a little bit. So that is 1/2 times. So first here we'll put a 1 here. So this, and you can see this here. Well, actually I should have, let me just first erase this portion here. So, what I had meant to say was that this 2 and this 2, when you factor them out, they will simply cancel the 2 here on the bottom. So what we will have then is, okay, we don't need this 2 anymore. So that's a 1, then 1 again, and this x becomes a 1 for the upper limit, for the upper limit 1, right? And for the lower limit, it will be 0. But when we put x equals 0, what we see that both these quantities will be 1, and 2/5 minus 2/5 will simply be 0. So this is our final value for the desired arc length. Now let's extend our question to what will the surface area of the, this is really a crude drawing. Let me just use computer to draw this for you. So here is a surface of revolution, and I'm using what is called scientific notebook to create this, this revolution. So this was our original graph, and we revolved it around the axis of x. So what we shall be doing is, when we take the integral, as you saw in the deduction, that is, we will be adding all these tiny scraps, okay? And what we do for that is that we just use this rule that was deduced on page 177 of our textbook. So I shall just write that rule again for you. So recall again that this is our function. Let me just write it like this, okay? And we are calculating the surface area of the surface of revolution of the graph of this function between which interval, 0, 1, okay, around the axis of x, and according to the rule that we are using, it is simply the integral from 0 to how much? 0 to 1 to pi fx, right? Times square root of 1 plus square of fx. Remember, that's what your arc length component was. Okay, so here let me put that as a square, and here we have dx, and that is not fx, I'm sorry, that is f prime x, right? So you saw this, if you recall. Here we have 2 pi, we can just carry it out, right? So we pulled that out, and let me quickly erase it. And here we got our fx right here. And if you remember, we just calculated the value of this quantity as simply 1/2 of e to the 5 over 2x plus e to the negative 5 over 2x, as in the original function. So this will simply change to, we are going to substitute. So substitute, and let's see. This is gone now. So we will just substitute the other value in here. So this simplifies to what? This simplifies it to, one moment here. So you can see this 1/2 will be cancelled by this 2 outside here, because that's a constant. And then what we will have is this, we'll simply have this quantity squared. And if you recall that if you go ahead and FOIL it, and before foiling, why don't we do this? That is, just pull that 5 or 1/5 out. Okay, and we got this. So you may fast forward me because I'm going to show you again those foiling details and repeat myself. So when you square this quantity, what do you get? You get simply e to the 5x, or as we did before, and then you get plus 2, or you can put 2 at the end if you would like, and then when you square this 2, because these two, when we look at the product term, they cancelled as you saw before. Okay, and then at the end the other square would be how much? E to the negative 5x. Then using the substitution rule, what do we get is this, that is we shall get our integral as right here. First we get e to the 5x over 5, okay, plus for 2 we will have 2x, and then we will have minus integral e to the negative 5x over 5, and on the top we have a 1, and the bottom we have a 0, and then what we have next is that if you look at it, when we put x equals 0, this whole thing will become 0 because the middle is 0, and these two will cancel each other as e to the 0 will be a 1. So all that we have is, we just have finally this quantity x substituted as 1 in here, okay? And if the question does not ask you to give the exact value, you can always give an approximate value by using your calculator, okay? So as you can see here in Desmos, I went ahead and entered our function, and then I entered the integral, okay? And it gave us an approximate value of the surface area that we have to find, all right? So now let's look at the homework problem that you asked for here, which was to obtain the surface area of the surface of revolution of 3 square root of x from 1.2 to 4.6. Okay, so here is the question. So let me first scroll it up here. And now what we will do is this, that we shall use the same rule. Just a moment, let me just change it in general notation that we used before. Now our lower limit is 1.2 and the upper limit is 4.6, okay, and our fx is 3 square root of x. So let's go for f prime x. What that will be, let's just use the chain rule here. So what will that give us? 3, because this is x, this is simply, as you know, this is x to the power how much? 1/2, right? Okay, so when we do that, then 1/2 will just step down by power rule, and we will get x to the power 1 minus 1/2, which will become negative 1/2. So this is going to be 3 over 2 x to the negative 1/2, or for shorter symbol, we can write it as square root of x here, and our territory is 1.2 to 4.6. All right, so let's calculate this quantity right here for convenience. So this would be how much? 1 plus square of this quantity, right? So let's square this here. And then that becomes square root of 1 plus, what that will be, 9 over 4x, all right? So 9 over 4x. Now if you take 4x as common denominator here, then the two will combine to how much? here you can write that as 4x over 4x. I'm taking you back to baby algebra, right? Okay, sorry, 4x, and this would be how much? Square root of 4x plus 9 over 4x, square root of actually. Okay, so square root of 4x. All right, so when we substitute all that in here, let's see what we get. So fx is how much? Fx is simply 3 square root of x. So sorry, so let's write it here. Okay, 3 square root of x, and this quantity we just found as this, right? Okay, so this would be, let me go just like across here, so that, so square root of 4 will be 2 square root of x is square root of x, and what will happen now is we will have some cancellations, okay? That this square root of x will cancel this square root of x, and this 2 will be cancelled by this 2. So this will be, sorry, okay, here, so this 2 is out, and this 2 is square root of x, and this square root of x, they went away, so it just cleans up to how much? It just simplifies to this, and I forgot erasing this 2, and let's pull this 3 out. All right, now here what you can do is you can use the substitution rule. Just take 4x plus 9 as u, and it will very easily simplify to, okay, you can go ahead and use decimals or any other calculator, or you can just go ahead and use substitution rule and get the exact value if that's how the answer is wanted to get the answer. So for an approximation, I'm just going to go to my older screen and just change x to 3 square root of x, right? And here change these limits to the limits that we had there, 1.2 to 4.6, and then, oh no, here I messed up, I'm sorry. Okay, 1.22 here, 4 point, oh wait, it's not, okay, here it is. Okay, it looks like my battery is going bad over 4.6. So this is an approximate answer.